Are you able to see my screen? Are you able to see my screen before I start?
Yes, sir.
You are able, right?
Yes.
Okay, so let me mute. Let me mute. Okay, fine. Let me mute all of you. We start. All right, so welcome to Huawei Network Security, which is called Huawei Certified ICT Associate Security version 3. So this is the latest version 3. So this is the exam code H12711. Okay, and then the duration of the exam is 90 minutes. Okay, and then you are given 60 questions. All right, so you have 3 types of questions. The first one is where you choose whether it's true or false. The second type is multiple choice, where you pick a single answer. And then the third type is multiple choice, where you pick more than one answer. Okay, so the tricky part with the last type of questions is that they don't tell you how many answers to pick, but they just say it is multiple choice. So it is up to you to decide which of the answers are correct. So for you to pass, you must get 600 and above. So 600 out of 1,000. Okay, that's how it is. All right. Let us look at the composition of the exam with respect to the modules that we're going to cover. So this course has 5 modules. So this is the first module, security information and security overview. So the first module makes up 10% of the exam. Then this is the second module, operation system and hot security. So this one makes 10% of the exam. And then we have network security access. This one makes 30% of the exam. Application of encryption and decryption, it makes 20% of the exam. And then lastly, safety operation and analysis. This one makes 20% of the exam. Okay, so this is how it is. All right, looking a little bit in detail about what we're going to cover. So this is module 1, and this is what we're going to cover in module 1. Okay, so we're going to look at information security standard and specifications, basic network concepts and common network devices, common information security threats, threat defense, and information security development trends. This is what we're going to cover today. Okay. Module 2 is operating system and host security, sorry. So this is where we're going to look at operating system overview, okay, common server threats and types, the host firewalls, and antivirus software. Module 3, we're going to look at introduction to firewalls. You know, what is a firewall? Okay, network address translation, which we call NAT. Okay, dual system hot standby. And then we're going to look at the overview of intrusion prevention systems. What are these? Okay, you are going to learn later about them. And then module 4, this is where we're going to look at encryption and decryption mechanism, the PKI, the public key certificate system, and then the application of cryptographic technologies. Okay, the last module will look at the introduction to security operations, data monitoring and analysis, digital forensics, very, very important topic. And this one, it is a course on its own. And then also we'll look at cybersecurity emergency response. Okay, so already, you know, I gave you the material, this one here, the course. You have this. So these are our notes. And of course, you have to start reading now. Okay, and then these are our labs that we are going to do. So the thing is, what you do in this course is what you are going to do at work. Very, very important. So I also gave you the lab menu. You have this. So you have to start now studying because the exam is very, very serious. So as you can see, the certification exam, Huawei has made it free for you. So of course, you must utilize this moment, because the way it is that the exam is $200, but for you, it has been given for free, okay? All right, so this, of course, will be my third group, okay? It will be my third group. In my first group, I had 28 students, okay? And of those, only 13 passed the exam, you see? And then in the second group, I had 22 students, and only 5 managed, okay? So the thing is, this exam is easy to pass. What you need is you have to study extra hard, you know. Nothing just comes on a silver platter. You have to work hard. You have to study hard. Very, very important. So if those, now I have 18 so far. 18 of my students have passed this exam. So it means that you can also do it, okay? You can also do it. All right, so for today, what we're going to cover, so these are the modules I was talking about. So we are going to cover module 1 today. And when I open module 1 here, I have 5 slides. So today, we will only cover 4 slides. Okay. So we are going to start with our first slide, which is basic concepts of information security. Forward, information security is the process of ensuring safe data communication and preventing issues such as information leakage, that is, the information has gone to unauthorized users, okay? Information modification, the changing of information, as well as disruption. That is, this is a situation whereby legitimate users are not having access to information. So information security is the process of ensuring safe data communication and preventing issues such as data leakage, modification, and disruption. This document describes the basic concepts and protection measures of information security, as well as information security risks and associated assessment and avoidance methods. The objectives. Upon completion of this course, you'll be able to describe the definition and characteristics of information security, explain the characteristics and differences of security models, lastly, differentiate between security risks. Contents, so we'll start by looking at information and information security. So what is information? Okay. Information, it is something that makes sense. Okay. Of course, what we can have, we can have data. Okay. Data is something which doesn't make sense. But when information starts making sense, when data starts making sense, it becomes what we call information. Okay. So this is how it is. Okay. So this information, it can be in different forms. It can be in form of books, letters. It can be in form of emails, transaction data, state secrets, radar signals, and test questions. This is what we call information, because it makes sense. Okay. So according to ISO, information is defined as information created, received, and maintained as evidence and information by an organization or person in pursuance of legal obligations or in the transaction of business. Okay. So that is information. Now, what is information security? Okay, what is information security? So before we start looking at network security, we are looking at information security. Very, very important that you understand. Okay, so information security refers to the preservation of the confidentiality, integrity, availability of data through security technologies. Okay, so it is the preservation of confidentiality. Okay, when we talk about confidentiality, here we are trying by all means to make sure that data is not disclosed to unauthorized, persons. That is confidentiality. Okay, and how do we achieve confidentiality? Okay, we can achieve confidentiality through what we call encryption. Okay, encryption. And what is encryption? Okay, encryption, this is where we take information and we move that information through mathematical formulas such that it becomes scrambled, so that even though it has been intercepted, a person won't be able to read what's there. Okay, that is confidentiality, encryption. Integrity, here we are trying to make sure that information is not altered. This is integrity. Okay, we make sure that information is not altered or hasn't been altered. Okay, and how do we achieve integrity? We achieve integrity through what we call hashing. Okay, we're going to look at that later on. But what is hashing? Again, with hashing, we get information and we pass this information through the hash functions such that in the end, it is going to generate a fixed value. Okay, that fixed value is what we call a hash, or what we call a message digest. Okay, and I think you have seen sometimes when you are downloading software, okay, when you're downloading software, you find that they'll put a hash there, MD5 hash or SHA. It is a value. Okay, so when you download that software, you must have also on your laptop maybe an MD5 or SHA calculator, such that you pass the same software through the calculator. Okay, so once you have done that, the hash you have generated on your laptop must be the same as that on that website where you downloaded the software. So that shows that while you were downloading, no one tampered with the software, because you have generated the same hash value. Okay, we are going to look at that later. And then availability. Availability here, this is where the workers have got access to information. All right, we are going to look at an attack called a DOS attack, which is denial of service attack. Okay, so this is an attack, or what we call a DDoS, which is different from a DOS attack. A DDoS, this is distributed denial of service attack. So with DDoS, the attack comes from multiple sources. So what they do is they do bombard a website with so many requests such that legitimate users are not able to access the servers. So the information won't be available. Okay, so this is what we call the CIA. So this is what we call the CIA triad. Okay, so these are very, very important in information security. So of course, we are preserving confidentiality, integrity, and availability through the use of security technologies. So these technologies include computer software and hardware, network, and key technologies. Organizational management measures throughput, throughout the information life cycle, that is during generation of information, transmission of information, exchanging of information, processing of information, and storage. Okay, so management has to be involved in all these stages of information. So the following will be affected if information assets are damaged. Very, very important. So you can see here, national security. Okay, national security, of course, it can be affected, like what we saw in the US, where they were saying that, you know, Russia hacked them during the elections. Okay, system operating and continuous development, as well as personal privacy and property. Okay, so these are some of the things that can be, you know, affected. So the aim of information security is to protect data against threats through technical means and effective management. So the thing is, when we have information security, we do not only rely on technical means. We are supposed to have also effective management. And what comes from effective management? It is training, okay? Training the workers so that everyone in the organization must be security aware, okay? Management are the people also who come up with the budget, you know, where to spend the money on. So they must be fully involved. Okay. Information security development. So this is the development of information security. So you can see it started in the early 90s. And this was called communication secrecy stage. So during this time, you know, there was limited communication technologies. So what they used to do here was to implement physical security. You know, that is, to the systems, access was being denied. So as long as that was done, then information was secure. Then post 1960s, this is what we call information security stage. So here we had internet development, you know, which brought about new challenges and threats to information security. So you find that computers were being connected to the internet, and that was increasing what we call the attack surface, okay? And then 1980s, this is what is known as information assurance stage. This is where we have information-based security replacing traditional security. Okay. All right. Now, when you see here, is this a photo or it is information leakage? All right. So this is information leakage. Okay. So this happened when China discovered oil at Darkwing oil field. All right, so the Chinese government decided to invite the bids for oil production equipment. You know, then the Japanese had access to this photo here, which gave them, more information about the location of the oil field, as well as the diameter of the oil well. So, the photos, they do carry sensitive information. All right, so this is the communication secret stage. I've talked about this already. So this is in the early 1900s, where communication technologies were, underdeveloped, and data was stored in different locations. So, information system security was limited to physical security of information and cipher-based security of communication. Okay. So as long as information was in a relatively secure place and unauthorized users were prohibited from accessing the information, data security could be generally guaranteed. So these, during this stage, they depended on physical security, okay, to make sure that unauthorized persons are not, accessing the information. Then we have information security stage. So this was in the 1990s. So this is the time where we had rapid development in internet technologies. And this led to an increase in information leakages. Okay. So as a result, so in addition to the CIA, which is confidentiality, integrity, and availability, information security began to focus on more principles and objectives. So they added controllability. So this has got to do with monitoring the systems as well as non-repudiation, okay? So non-repudiation, this is a situation where the sender cannot deny that he's the one sending the information, okay? So you can see more principles and objectives were added. So at first we had confidentiality, integrity, and availability, okay? And then to this was added controllability and non-repudiation. Okay, information assurance stage. So this is business-oriented information security assurance, right? Where we have to look at business, and this has different service traffic with various risks and protection methods. And then we have security system, where we have cohesive security management and technical protection, where we talk about what is known as proactive defense. That is before an institution is hacked. You already know that that our institution is about to be hacked, and you put in some measures. Okay, management, which has got to do with talent development and system establishment for security management. So remember, I said that we are not supposed to have only technical measures, but also we are supposed to have management measures in place, where talent has to be developed by training the workers, okay? And also, it is through this where an organization can come up with a document which is known as the security policy. So this is a document with content of how we are supposed to protect our organization from the threat actors. Okay, so we're going to look at two cases which happened not long time ago, which has to do with information security. There was the WannaCry ransomware in 2017, okay? And this is crypto worm. Okay, so what is a crypto worm? So this is a malware which is able to encrypt the information that you have on your machine, okay? And you can see that it infected over 100,000 computers, causing a loss of 8 billion US dollars. So the energy industry was affected. Transportation was affected. Government systems were affected. The schools were also affected. So the thing in what happened here was that Windows had a vulnerability. What is a vulnerability? This is a weakness in the system or its design, okay? So the Windows operating system, it is made up of millions and millions of code, you know. So the coding is done by we humans, you know, so we make mistakes, okay? So where we have made a mistake, there we are going to have a weakness or what we call a vulnerability, all right? So what hackers do is to exploit that vulnerability, that weakness, and to get into our system, okay? So Windows had the vulnerability, and of course, Microsoft did release the patch to mend the weakness. So some people didn't patch, okay? Therefore, hackers came up with the WannaCry ransomware, okay? And the systems which were not patched were infected. So what you see here, you know, your screen is going to be blocked with this new window here, as you can see. So there's nothing that you can do on your system. All right, so what information is here? You know, there will be the time which will be ticking, okay? And then here, there's a point, there's information, how you are going to pay the ransom. Of course, the payment has to be done in Bitcoin so that they won't be able to track the hackers, okay? And of course, there'll be one point where you're supposed to enter the key that the hackers are going to give you to decrypt information. So WannaCry ransomware encrypts information. So you need a key from the hackers to decrypt the information. For you to decrypt the information, you have to pay a ransom to the hackers, okay? So this WannaCry, of course, it took advantage of the vulnerability in port 445 in Windows. So this is another case, OceanLotus. So since April 2012, this group has been launching cyber attacks against a number of important sectors in China, such as the government, scientific research institutes, maritime institutions, and so on. So this group is intended to obtain confidential information, intercept intelligence, all right? And of course, this group uses two methods of attacks, okay? So the first method which they use is what we call spear phishing attack, okay? So what is a spear phishing attack? So this is a targeted attack where the hackers can target an institution or they can target an individual working in that institution. That's how it is. Okay, so they use spear phishing. And then the other method which they use is what we call watering hole. Okay, so what is a watering hole attack? This is where the attackers can identify an institution, and then they can identify targets in that institution and be able to know the websites which, those people in that organization like visiting. So what the attackers are going to do is to infect the website which the individuals in an organization like visiting, okay? So this watering hole, this concept was taken from here, from Africa, right? Where, we have national parks, okay? And the lions, of course, they would go to places near the water where they know that these other animals will come to drink water. So that is what we call a watering hole attack, okay? So these are some of the cases, cyber attacks that we have, okay? So what are the causes of such attacks? We have direct cause and indirect cause, okay? So these are the direct causes: viruses, vulnerability. This is a weakness in the system. The Trojan horse, okay? A Trojan horse, this is a program which you can be thinking that it's a good program, for example, a video game, but in the background, it is doing something else. And then backdoor programs. So with backdoor programs, when the hackers hack an organization, they would want to maintain communication with those hacked systems. So what they do is to create the backdoor. And then this is DDoS attack, distributed denial of service attack, okay? So with this attack, the hackers or the attackers, what they do is they are going to infect systems on the internet, okay? Those infected systems, we call them zombies. And these infected systems, they create a network, which we call the botnet. And the malware, which is used to infect these systems, is called a bot, okay? And then the person responsible for the botnet is what we call the boot master. So it's going to program those zombies in such a way as to send a large amount of traffic to a single target, let's say a server. So that server will be bombarded with so many requests such that, bandwidth will be consumed, the CPU will be made busy, RAM will be consumed, such that legitimate users won't have access to the server because the server is now confused. Okay. And then we have indirect causes, which comes as a result of one, information system complexity. Okay. So this is where we have one, a complex process. Okay, a complex process whereby the designers of systems, they put more work, in making the system to be usable. They are putting security to be, the second choice. Okay, and then also we have complex structures where you have got this system and it has got so many terminals. Having so many terminals to a system, or having so many components, that creates a bigger, attack surface. That is, it creates, or the system is going to have a number of points which hackers are going to use to enter into the system. Okay. And then the other thing is a complex application. Okay, so we have got complex process, complex structure, and also complex application. Okay, so what is complex application? In a network, you'd want that, let's say, instead of having a device called a router, that is having a single router which is connected to the internet, you can decide to have 2 routers or 3. This process is what we call redundancy. So it is going to create, you're going to have so many devices and so many connections such that, it will be taking time for you to locate the error and rectify the error. Okay, that's how it is. So the third, the second indirect cause here is human and environmental factors. Okay, maybe we have the floods. Our organization has been flooded, or maybe it is earthquake, and so on. Okay. Significance of building information security. So we have increasing importance. So the information network has become the foundation of economic prosperity, social stability, and national development. You are now able, you are learning in this way. It is because of the network. Okay? It is because of the network. And then informatization profoundly influences the global economic integration, national strategy, adjustment, and security what? Priorities. You know what the internet, does for us. So information security has transformed from a technical issue into a matter of national security worldwide. So you find that here, the electric grid, they are also connected to the internet. They are run by the computers. Okay. The water system is run by the computers. Okay, so this is very, very important. Okay. Applicable to many technical fields, command, control, communications, computers and intelligence system, the e-commerce system, biomedical system, the intelligent transport system, all these, they use technology, and therefore they must be protected at all cost. So you can see the importance of, information security. Move on to our second content, which is information security risks and management. Risks involved information security. So we have got a number of them: physical security, network security, system risks, information risks, application risks, management risks, and others. Let us look a little bit in detail about these. Physical risks. So physical risks involve device theft and destruction. So you see, the devices that you have in your organization must be protected, laptops and so on, from theft and destruction. Okay. The other physical risk that we have: link aging, man-made damage, or the bites from animals, chewing the cables, network device fault, and then network device unavailability due to power failure, electromagnetic radiation in the equipment room. So you see, it has become complicated such that hackers are able to steal information from electromagnetic radiation, which is coming from the systems when they are working. So you have to protect your server room with the devices which are not going to allow the electromagnetic radiation to move out of your organization. So these are physical risks. Information risks that we have to look at: storage security. How do we protect information at rest? Transmission security. How do we protect information in transit? Okay, as well as access security. How do we protect, or how do we restrict access to our system? So this is information transmission security. So this is the headquarters here. This is our branch. The information is passing through the internet, and then the attacker can be able to be intercepting this information, as well as maybe tampering it. Okay. And then this is information access security, whereby we have an authorized user here, having access to our system through illegal login. System risks. This is where we talk about database system configuration security, security database, security of services running in the system. And then with application risks, this is where we have to talk about network viruses. Okay, we have to look at operating system security. What do we do here? We have to make sure that the operating system is up to date. Okay, email application security. Okay, so here we make sure that we have the email filters. Okay, web server security, service security, FTP service security, the DNS service security. Of course, what we have, we use DNS a lot. Therefore, it is a target by hackers to use it either to bring malware into your organization or to steal information from the organization. That's why now we have what is known as DNS over HTTPS. And then we have business application software security. Network risks. So with network risks, you can see this is the internet, okay? And then we have the firewall here. This firewall, it can be divided into what we call security zones, okay? Security zones. And what we do configure on this firewall are the policies. So we can say, and of course, these zones, they have what are known as security levels, okay? So we can have our internal network. So this internal network, or let's say, let me just divide this into two. We have this zone, I can say zone 1, and then this is zone 2, or I can say this is a trust zone, and this is the trust zone. So when traffic is moving from the trust zone going to the other trust zone, we won't put restrictions on it, okay? Or I can have this as a trust zone, and then this one as untrust zone, whereby I can have a policy on the firewall saying that the traffic which is coming from the untrust zone doesn't have to be allowed to come to the trust zone. So the configuration of those policies, that is what this course is all about, okay? Network security. Management risks. Determine whether information system has management risks from the following aspects. So we have to use the national policy, okay? So in the national policy, this is where we can have regulators, they come up with regulations, all right? That is how organizations must manage information security, all right? So these regulators, of course, they have the auditors who have to visit your institution to check whether you are following their regulations, okay? Enterprise system, so this is security management rules and equipment room management system with clear responsibilities and rights. So you see, the organization has to establish its own security what? Management as well, okay? And then we also have management system, okay? So this is where we have effective security policies and high quality security management personnel. So these can be able to do the internal audit, okay? So significance of information security management. So this is what we have here, okay? So according to statistics, 70% of enterprise information loss is caused by negligence or intentional leakage by internal what? Staff, 70%. So we have only 30%, which is coming from the technologies that we have implemented. So this indicates that security technologies are not the only means to control information security. Management must be involved, okay? So we have to involve management as well. Current development of information security management. So we have here, introducing information security development strategies and plans. So each country has to have this, must have its own information security development strategy and plan. This is very, very important for us to have order. And then, of course, we have to strengthen registration. as far as I know, the Zambian cybersecurity law, I think it is still in parliament. So we must have the laws in place. Okay. If someone has committed a cyber crime, how are you going to prosecute that person? Okay. Entering the era of standardized and systematized management. Okay. So we have the era of standardized and systematized information security management, which began in 1990s. So we have some organizations such as ISO. These, they have come up with documents which organizations can adopt as their own. You know? So this document, it has information of how the organization can beef up, you know, information security. So very, very important, you know, institutions. Okay, so the quiz. So this is an example of some of the questions that you have in your exam. So the mistakes which most of the people make is panicking. You know, you don't have to panic. All right, so you have to take your time, you read the question and understand. So information security incidents frequently occur because of security attack methods, such as vulnerability, viruses, and backdoor programs.
True.
So you can see here that these are not the only methods. They are a lot. Therefore, the answer here is what? 4. So make sure that you read the question and understand the question. All right. Okay, so we move on to our second slide for today. So this is our second slide. This is information security standards and specifications. So what we are doing, you know, is, you know, a boot camp where we need to cover so much material in a short period of time. Forward, the process of information security system construction, enterprises comply with international standards and specifications to develop their own security specifications and improve operations. This document describes and analyzes several international information security standards to help better understand information security. Okay, so upon completion of this course, you'll be able to describe common information security standards, describe significance of information security standards, and then also describe many points of common information security standards. This is our content. Okay, so we'll start with information security standards and specifications. Significance of information security standards. So standards are normative documents that are formulated, approved by recognized authorities and used throughout the industry to achieve the best security. Just a minute, I mean, there's some noise. So the standards, you know, they do teach organizations a lot, you know. Of course, how can an enterprise build a secure information system? Okay. Implementing each step according to international authoritative standards. So standards like ISO, they are very, very important. They come up with a document recognized by so many authorities. And this document, of course, is made by people from different countries. So these are information security standards organizations that we have. Okay. So we have ISO. This is a very, very important organization. And of course, it has come up with a number of standards that are used in different fields. And then we have the International Electronic Commission, IEC. This is an organization which has come up with standards in electronics and electrical, okay? And then we have other standards here. For example, China Information Security Standardization Technical Committee. These are, you know, the organizations from China. And then we have the International Telecommunication Union. This is a special agency of the UN responsible for telecommunication. Okay, so it comes up with standards in telecommunications. You know, it helps in the development of telecommunication in the developing countries. Okay, this same organization is also responsible of allocating, you know, radio frequencies and so on. And then we have also this other organization, the Internet Engineering Task Force. So this organization, you know, it consists of network operators, network designers, who make sure that there is order on the internet. Okay. Common information standards and specifications. China has got its own, which is called Graded Protection Information Security. Then we have ISO 27701. The US has its own, which is Trusted Computer System Evaluation Criteria. EU has got its own, which is Information Technology Security Evaluation Criteria. So we'll start with looking at ISO 27701, ISMS. This is a framework, you know, a policy, and also it has got procedures, okay, which your organization can adopt when they are trying to implement information security. So this is Information Security Management System. It is based on the British standard, which is the BS 7799. So the ISMS has the following stages. The first one is planning. So this is where you have to establish ISMS, you come up with policies, you come up with procedures, okay? And then do. This is where you implement and operate those policies and procedures, okay? Check. This is where you monitor and review whatever measures you have put in place, okay? And then, of course, action. This has to do with maintaining and improving ISMS, okay? So the ISMS, it is a document which has information of how your organization can be able to secure itself, okay? And one of the things that ISMS has is this cycle here. Plan, do, check, and what? Act, action, okay? So the ISO 27000 family of standards, these are in two groups. We have group 1, which deals with requirements and supporting guidelines. So these are the ones here. There's group 2, which deals with audit and certification guidelines. And then we have group 3, which deals with information security management requirements. And then we have group 4 here, which deals with health information security management standards, which is ISO 27799. So it deals with health information standards. Okay. ISO 27001 evolution. So it came from the BS, which is the British standard 77992. Okay. And then we have the ISO 27002, which came from the BS 77991. Now, you see, how can your organization implement the ISMS? Before implementing the ISMS, your organization has to know about the requirements and standards for implementing and establishing security management system. Okay? And these requirements are in ISO 27701 for you to implement the ISMS. Okay? So apart from this standard, we also have other standards like ISO 27002, okay, which deals with information security management operations. And of course, it comes from the ISO 27701. Okay. So you can see that the ISO 27702, it has 35 control objectives, okay, 113 controls, and 14 categories. So these are the 14 categories, okay? So when you look at category 1 here, this one deals with information security policies. It deals with organization of information security. Anything that has to do with organization of information security, you're going to find it here. Human resource security, you find it here. Asset management, you find it here. Because when you'll be implementing information security in your organization, you must be aware of the assets that you have. An asset is anything of value which an organization has. Okay. Anything to do with access control, you find it here. Cryptography, okay. Physical and environmental security, operation security, communication security. So these are separate documents, okay. System acquisition, development and maintenance, supplier relationships, okay. Information security incident management, how you're supposed to handle a security incident, you find it in this area here, okay? And then information security aspects of business continuity management. So business continuity, that is, if our site, we have an earthquake on this site, how do we continue functioning as a business? Maybe we can have a cold or a warm or a hot site somewhere. That's how things are done. And then compliance. So this is the ISO 27001 project information methodology and steps. Okay, so this is step 1. So step 1 is in plan. Remember the plan, do, check, and action. Okay, so this is where we, you kick off the project with meeting, you set up the team, what should be in the security, and so on. Risk assessment, okay, training on asset correction and risk assessment methods. It's done here in planning. System design and release in planning. And then system operation and monitoring, which has to be in do. So this is where you have development of the information security management performance monitoring process, ISMS, trial run, okay. Also check is here, certification and continuous improvement. So this is where you have now ISMS, internal audit. It has to be done. Those measures you have put in place, are they really working? Or have they been done properly or not? Or you can have ISMS, external audit. Of course, this, there are some people who provide such services, okay, or it comes from the regulators, okay. Graded protection of information systems. So of course, we said that China has got its own graded protection of information and information systems, which has national regulations and requirements. It then has also the supervision by Public Security Department. So these regulations, they have to be supervised, and then they have to be implemented by the headquarters and the industries. So this is where now, if the institution does not implement the regulations, okay, this is where now they go and pay a penalty. This is very, very important, and this is the only way of how some institutions, will get heed to the regulations. All right. So you can see why having the graded protection in place. It improves protection and resource allocation. Okay, improving the overall protection. Okay, that is effectively improving overall information security assurance and resolving threats and major issues faced by information systems. So this can only be achieved if you do what is in the graded system. Okay, optimizing resource allocation. Okay, so this is as good with investing limited financial, material, and human resources in key areas to maximize economic benefits of what? Of security. Okay. So this is the background of the graded protection system which China is using. So you can see between this period, this was an initial stage. And then between this period, there was a development stage. And then 2007 up to now, This is what we call the promotion stage. Very, very important that, a country must have this in place. The scope, protected objects. So it covers big data, information systems, basic information network, okay? So an information system, it covers industrial control systems because these are also targets of hackers, Internet of Things, where now we want to join those devices which were not connected to the internet. We call that the Internet of Things, cloud computing platforms, okay, information system using mobile internet technologies. So you can see the grades. Here we have got the grades and the damages in relation to the rights and interest of citizens and legal persons, damage in relation to social order and public interests, and damage in relation to national security. So when you look at grade 1, there's just, it damages only legitimate rights and interest of citizens. It doesn't apply to social order and national security. The damage when it's in grade 2, severe damage to legitimate rights and just a damage to social order, but not a damage to national security. Grade 3, you can see here, severe damage, legitimate rights, severe damage, social order, and just damage, national security. And then grade 4 here, severe damage, legitimate rights, severe damage, social order, and severe damage, national security. And then when we are in grade 5 here, throughout, we have severe damage. Basic technical requirements. So each grade of protection has corresponding technical requirements. For example, the technical requirements for grade 3 covers 5 aspects. So grade 3, it covers physical security, app security, application security, data security, network security, which we are dealing with, and host security. So network security has 7 control points and 33 items. So this is where we look at structure security, access control, okay, security audit, okay, the boundary integrity check, intrusion prevention, malicious code program, and network device protection. So this is the process for graded protection, which has started with grading. So this is the primary step of graded protection, filing, mandatory procedure for notifying the Supervision Department of Graded Protection Construction, assessment, methods to assess the status of security protection, rectification key to the implementation of graded protection, and of course, supervision, which has to be done by external management of graded protection. So other standards that are there, we have the Trusted Computer System Evaluation Criteria. So this is in the US. So you can see it has A, which is known as verified protection, okay, and then B, mandatory protection. So with mandatory protection here, security is graded into what we call security levels, okay? So for example, in the military, they do classify data. Let's say you have top secret, secret, and so on, okay? So someone who is supposed to view top secret information, he must have the security clearance for that level. That's how it is here with mandatory protection. We have discretionary protection, okay? So you can see here, audit protection is available. Users' actions and responsibilities can also be audited. And then we have got D with minimal protection. And then this is for Europe. Okay, so this is information technology security evaluation criteria for Europe. As you can see, from F1 to F5 level, this is the same as that for the US for levels D up to A. And then we have F here, which deals with data and program integrity, F7 system availability, F8 data communication integrity, F9 data communication confidentiality, and F10 here network security, including confidentiality and integrity. Other standards which are there in the US, they have what we call Sarbanes-Oxley Act. It's called SOX. Now, this act is very, very important. The US came up with this act to protect the investors. So the way it was a long time ago was that, the companies, they couldn't disclose their true financial standing to the people. So the people would invest and then lose money, okay? So what this act does is to compel organizations to disclose to the public their true financial standing, okay? Very, very important act. Okay, so the quiz. So this is the second type of questions, multiple choice. All right, so which of the following are internationally known information security standards organizations? So here we just have two, ISO and IEC. The ISMS complies with the dash process. So you don't have such type of a question, okay? But it has the plan, do, check, and act process, okay? So in this course, you make sure that you read and understand each and every sentence that is on a particular topic. All right, so when you are supposed to pick more than one answer, you are going to be shown that, you have to pick multiple answers. All right, so let us move on now to our third lecture for today. So this is basic network concepts. So very, very important that you must have knowledge on networking. Forward, to understand security technologies, you first need to learn about basic network concepts, such as basic communication principles, network components, and common network protocols. With knowledge of these basic concepts, you can better understand network security threats and deploy security defense policies. Objectives: upon completion of this course, you'll be able to describe the working principles of TCP/IP protocols, describe the working principles of common protocols, describe possible security threats to common protocols. Contents, we'll start with TCP/IP architecture. So this is an architecture of a typical campus network. All right, so this is how it is. So it has layers. So this is the access layer. So these devices that you have, we call them switches. So this is where you connect laptops, PCs and IP phones. So this is the first layer. It's called access layer. Then this is the second layer. It's called aggregation layer. Okay, so in this layer, this is where now, the thing is, first of all, we have what we call a LAN, a local area network. Okay, so this is a network which can just cover a single building. Okay, so we can have another local area network in another building. When we want to join these, we join them here at the aggregation layer. Okay, and then this is the core layer. This is where now we have powerful devices here because they handle a large amount of traffic. So this is where now we are connected to the internet. Okay, remember I said, this is what we call redundancy. Instead of having one, we have two, such that when this one fails, this one will continue what? Functioning. The same applies here. This is what we call redundancy. Okay. So this is the computer, design. Okay. It is designed according to the layers, the access layer, aggregation layer, and core layer. OSI model. What is this? Okay. The purpose of having the OSI model is to easy interconnection of devices. What are the design principles of the OSI model? Okay. So the first principle is that this OSI, it has different layers, and each layer has a particular function. Okay. The other principle is that each layer is a service user as well as the service provider. Okay. And then the other principle is that these layers, they cannot overlap. Okay. That's how it is. We have the OSI model because it helps us to easily understand networking. So that is one advantage. Okay. And again, the other advantage is that, it helps the manufacturers of devices to manufacture the devices which are going to interoperate. Okay. So what do I mean? We can have, for us to have wireless network, we're supposed to have an access point. So an access point, maybe it can be from HP. Okay. But that access point will be able to send the signal to my laptop, which was made by Dell. The other laptop was made by maybe, Huawei and so on. So those are some of the advantages of having the OSI model. So it simplifies the way we understand our network. So this is the OSI model. It has layers. You can see the physical layer, data link layer, network layer, transport layer, session, presentation, and application layer. Okay. So this helps us to easily understand the network. Okay. So when we talk about the application layer, this is where we talk about applications, for example, the browser. Okay. When we talk about the physical layer, This is where we talk about, the cables and so on. Okay. So now, from here up to somewhere this side and up, this part is in the operating system. It is in the operating system. So each layer has a function. So the function of layer 7 is to provide communications between applications. Function of layer 6. So here, application layer is also called layer 7. Presentation layer is called layer 6. Okay, and so on. So in the presentation layer, this is where we, there's processing of data formats and encryption of data. Session layer, layer 5, it creates, maintains, and manages sessions. Transport layer establishes end-to-end connections between hosts. Network layer performs addressing and routing. Okay? And then here, when we talk about addressing, what you must know is that for your computer to connect to the internet, it must have a unique address. And that address, we call it the IP address. So when you are sending something from here to New York, the internet is represented as a cloud, but what is there are the routers. They do routing. That is, when you're sending the traffic, the router has to look for the shortest path to reach New York. That's what we call routing. And then layer 2, this provides media access and link management. And then layer 1, which is the physical layer, this one, it transmits bit streams. Okay? So what we have here, we call it application protocol data unit. When it comes to this layer, it will be called presentation PDU. When it comes to this layer, it will be called session protocol data unit. Okay? When this reaches the transport layer, it will be called a segment. When the segment reaches the network layer, it will be called a packet. Okay? And then when this packet reaches the data link layer, it will be called a frame. Okay? And then here, this is where we have the bits. Now, when these bits, these are ones and zeros, they'll be changed into a signal when they're passing through the cable. Okay, that's how it works. Okay, so now, when this SPDU reaches the transport layer, to the SPDU, we are going to add the transport layer header. Once we have added the transport layer header, it will be called a segment. This process of adding the header to SPDU, it is called encapsulation. This segment, when it reaches the network layer, we are going to get the network header and add it to the segment. It will now be called a packet. When this packet reaches the data link layer, we are going to get the data link header and add it to the packet. It will be called a what? A frame. So you have to know these terminologies. Okay? So what we can have here is just data. But when it comes to layer 4, so you would hear layer 4. or transport layer, you know, it's called a segment, okay? They would ask, what's a PDU in network layer or layer 3? It's a packet. What's a PDU in the data link layer or layer 2? It's a frame. Okay, so this is how it works when you are sending information from host A to host B. This is what happens on your laptop. You start with the application layer. You're opening up the browser, okay? So here the headers will be added. Okay, so data will move through the cable. When it reaches the other PC, data will start moving up, okay? So when we are moving, that header we have added here, this time around we're going to remove. The process of removing the header is called decapsulation. Until the data will reach the application layer, that's when host B will understand that information. Okay, so apart from having the OSI model, we also have the TCP/IP model. These models are there to help us easily understand networking. Okay, so you see, we looked at the OSI model. This is the TCP/IP model. The difference, you can see it here. These first 3 layers will just give us application layer in the TCP/IP. The transport will remain. The network layer will become the internet layer. And then these last 2 will be combined into one, and it will become the network access layer. And of course, nowadays, this is what we use, okay? All right, so you see, just like I said, each layer has a particular function. And you can see that in the application layer, these are the protocols that are involved. You know, so when you are using web services, the protocol that is involved is HTTP. You are browsing HTTP protocol. And then Telnet is used when you want to manage a device which is very far. Telnet, okay? Now, Telnet transmits whatever you're doing in a clear text. Therefore, in place of Telnet, you must use SSH. FTP, when you are transmitting a file, the protocol that is involved is FTP, File Transfer Protocol, okay? You can also use TFTP when transferring a file, but it is not secure. And then this is domain name service, DNS. What does it do? Okay, so as I said, you know, the computer only knows 1s and 0s, okay? But for us humans, it's difficult to work with 1s and 0s, you know. So the IP address was changed to decimal values, you know, like 192.168.1.1. But again, dealing with numbers, it's difficult. So it's better for us to deal with words. For example, Google, okay? So when you want to go to the Google server, you don't have to know the IP address of Google. What you have to know is the word Google. So once you type the word Google, that word, it goes to the DNS server. So the DNS server has in the tables where it matches the word Google to its IP address. That's how it works. Okay. transport layer, here we have got two protocols, TCP and UDP, okay? How do we use TCP? For example, when you are sending a file, okay? When you are, sending an email, the protocol that is involved is TCP, Transmission Control Protocol. UDP is user datagram protocol. For example, what I'm doing right now, it's using UDP, videos, online streaming, the IP phones, they use this protocol here. This is the internet layer, and these are the protocols it has. IP, ICMP, okay? IGMP, ERP, and reverse ERP, okay? Then, network access layer, this is where I'll talk about what we call Ethernet. What is Ethernet? Ethernet technology, okay? In a local area network, let's say in my office of mine here, I have connected 10 computers. That is what we call Ethernet. And for these computers to communicate, they use another address, which we call the physical address or the MAC address. So your laptop has a physical address or a MAC address, okay, which it uses to communicate with the PCs which are in a local area network, the same network. Okay, that is Ethernet technology. So this is the standard for Ethernet, 802.3. This is another technology, point-to-point, HDLC, and frame relay. Okay, so you can see also here, each layer has a particular function, and this easily makes us to understand networking. Okay. So I talked about encapsulation and decapsulation already. This is the sender, this is the receiver, and you can see we're using now TCP/IP model. So we have user data, okay? Now you can see when you come to transport layer, we're going to add TCP header. The process of adding this header is what we call encapsulation, okay? So this is called what, if you remember? It's called a segment. And then here, we are going to add an IP header again to this. So once we have added the IP header, this process of adding is called encapsulation. And this now is called a packet, all of it. And then here, we add Ethernet, you see? It will now be called a frame. So you can see we have now ones and zeros, which have to be changed into signals. Okay, we reach this end. Now, here, we were going down. When we reach the receiver, we'll be going up. So you see here, we're going to remove this Ethernet, and then here, we are going to remove the IP, and then here, we're going to remove the TCP. So in the application, we're going to remain with this. That is when the receiver will be able to understand the received information. Quintuple. So what is quintuple? This is a combination of source IP address. So you see, in networking, we have the source IP address, as well as the destination IP address. For example, when you're sending a letter to someone, maybe at the village, what do you put on the envelope? You put your address, the source address, and the address where that letter is going. So that same principle is used by computers as well. Now, That process of getting a letter and put it in an envelope, that is what we call encapsulation. Okay. Now, when you want to reach these services, for example, the web, they use what we call port numbers. So these are what we call well-known port numbers, and they are fixed. Okay. So we have source port number and destination port number. Okay. On your laptop, when you open the browser, a source port number is going to be generated dynamically. Okay. So if it is going to HTTP, it is going to go to port 80. When you are transmitting a file, you're dealing with port 20 or 21. Telnet, it's port 23. And then SMTP, it's port 25. So SMTP, this is a protocol that is involved when you are sending an email. DNS, it's port 53. So you can see TCP is used by HTTP, FTP, Telnet, and SMTP. Okay. Why? Why? It is because when you're using TCP, when you send information, you're supposed to receive an acknowledgement that that information reached its destination. So when you do not receive acknowledgement, that data has to be resent. Okay? That's why when you're sending an email, you send it full. Or when you're sending a file, you have to send it as a full file. All the packets have to be received because anything can happen to the packets on their way when they are moving from here to New York. So that is with TCP. Here you have got acknowledgements. Okay. UDP, with UDP, we don't have acknowledgements. If you are sending data and that data is lost, it is lost just like that. Okay. So DNS uses both TCP and UDP using port 53. Okay. TFTP 69. And then Simple Network Management Protocol 161. We use this protocol in a bigger network when you are managing it. Okay. So these port numbers, they are associated with the services. They are very, very important. Okay. So we are going to assume this is your laptop. Okay. You have opened the web browser, a source port number is going to be generated. You have opened Skype, another source port number is going to be generated. So these, they will go. But when coming back, they have to come back to the original source port. So this makes it possible for you to open a number of applications on your laptop. It's because of the source port numbers. Okay, so common network protocols, we have the network layer protocols. Okay, so we have the network layer protocols such as IP, ERP, and then these are what we call dynamic routing protocols, OSPF and RIP. Now, and then the other one is ICMP. Okay, now, how do we use ICMP protocol? Okay, when you want to test connectivity between this PC and this one, we use a utility called ping. So we're going to go to the command line of this PC and type ping, you leave space, and you put the IP address of this device. So the protocol that is involved there is ICMP. Okay, we're going to look at ERP later. And then these are the routers. So these routers, they share the information about what they know. That's why this PC can be able to send this other PC, which is very, very far. It is because of these routing protocols, which have to be configured. And once that's been configured, then these routers, they'll share the information about how to get to this PC. Okay. Let me also talk about the routes. So we have different types of routes. There's what we call direct route and indirect routes. Okay. So to this PC, this is what we call a direct route, and this one, which are directly attached to the router. And then these are what we call indirect routes with respect to this router. Okay, these are direct routes. So we can classify routing into direct routes and indirect routes. Okay, we can also classify routing either according to the network address or the host address. Okay, or we can classify routing into what we call interior routing protocols and exterior routing protocols. But before this, we have what is known as static routing and dynamic routing. Static routing is normally used in a smaller network where the network admin has to configure the routes manually. But when the network is very big, there, you have to use dynamic routing protocols, which is automatic. So with dynamic routing protocols, we have what we call interior dynamic routing protocols and exterior. An example of interior routing protocols can be, let's say, MTN, Airtel, these internet service providers, Zamtel. So the routing protocols that are used within Zamtel, they are called interior routing protocols. And then the routing protocols that are used within Liquid Telecoms, they are called interior routing protocols. When you want to join Zamtel to Liquid Telecom, you use what we call an exterior routing protocol. Now, the interior routing protocols, they are further divided into what we call distance vector and link state. Okay? Distance vector and link state. Okay. So these are examples of, dynamic routing protocols here. We have OSPF here, which is link state. Okay. And then RIP here, which is a distance vector. All right, ERP. So what is the idea behind this ERP? Okay, this is a switch. Remember, I gave an example about my room here. Okay, so this is my room. This is a switch. So these devices are connected to the switch. So this is what we call a LAN, a local area network, or Ethernet. Okay, so you can see this device, apart from having an IP address, it has also this address. This is what we call the MAC address or the physical address. Excuse me. Now, host A wants to send information to host C. Okay, and I told you that these devices, they use the MAC address. So this host wants to send something to C, but host C only knows the IP of host C and not the MAC address. Okay, so what host A is going to do is to send a message which is called a broadcast. So if a message is a broadcast, it has to reach all the devices in a local area network. So this device will receive a message. And of course, in that message, host A is going to put the IP address of host C. So this host will receive that message, it will open that message and check, compare the IP address in the message with its IP address. If they don't match, it will drop that message. C will receive the message, compare its IP address with the IP address in the message. Once they match, C is going to reply that message, and in that message, it is going to put its MAC address. That is how host A is going to know the MAC address of host C. And that's when host A now will send the message to host C. So this process is what we call an ERP. Very, very important. There's nothing like memorizing here. You have to know the concepts. Very, very important. Okay, so this is the process. So A is going to send a message called an ERP request. So in this ERP request, you can see the destination MAC address is going to be OFs. When we have this address, it means that this is a broadcast. It is going to reach each and every device here. We have three types of the way these computers deliver messages. Unicast, that is when host A is sending to host B, and then mountcast, when host A is sending only to a certain group, and then broadcast, when it goes to everyone. Okay, so this is the message which is going to be sent here. And you can see that the destination address will be the address of this PC here. Okay. All right, so you can see now host C is going to reply. In the message, it is going to put its MAC address. Now, when you are on your laptop and you want to check what is in the ERP table, you have to use this command. You go to the command prompt and type ERP --A. So this shows you that host A really received the message from this host. You can see the IP address here. And its MAC address will be put in the ERP table. So this is what happens in a local area network. Okay. So we have another type of ERP called gratuitous ERP. Okay. How do we use this ERP? Okay. So when host A has been given an IP address and it wants to prove that it is the only one using that IP address, it is going to send a broadcast once more. Okay? You can see OFs, and it is going to put its IP address. So the devices will receive the message, open it, and compare the IP addresses. If they don't match, they'll drop the message. But if any of the devices, you know, the IP address has matched, it is going to reply to host A. That's when host A is going to know that there is another computer using the IP address that I have been given. Okay, so it will start communicating with the DHCP server to try to be given another IP address. So gratuitous app can be used to detect whether IP addresses conflict. Okay, so ICMP. So this is another protocol which is used to transmit error, control, and query messages. All right. So you see here, when you want to test connectivity between these two these two PCs, okay, you send a ping, and the ping has got two messages. It has an echo request and an echo reply. Okay, so we use ping to test connectivity to find out whether these two devices are reachable. Okay, all right, so you have to go to the command prompt of your laptop and type ping. When you don't know what to type, of course, this is on the router. When you don't know what to type, question mark, and then you'll be guided. Okay, and then these are what we call the switches. Once you put these switches here, they are going to change the output of your results. So you can see what these they mean. So when there's a connection between these two routers, so here you can say ping, and then you put this IP address here. When the ping is successful, you're going to receive replies from the other router. It will show you that 5 packets were sent and 5 packets were received. So this shows that there's a connection between router A and router B. Okay. All right. Now, there's another utility called Tracent. We use Tracent when you want to find out how the packet has moved from host A to host B. You know, so you have to say Tracent question mark, and then you can put the IP address. When you want to find out certain information, then you can include these switches in your command. Okay, so these are the results. Okay, that is, it is going to show you, you know, how many routers the packet moved. So you can see 3 routers. That's why we have got 3 information here. And the time it took. Okay. Routing protocol overview. All right, so routing is the most basic element in a data communication network. It's a process of directing paths on a network through which packets can send from a source to the destination. So I've talked about this already. So this is represented as the internet, the crowd. But what you have there are the routers. So for PC1 to reach PC2, these routers must share the path to host to PC2. So that is what we call routing. So the routers, they have to find, or they have to calculate the best path using routing algorithms. Okay. So OSPF is one of dynamic routing protocols, which is used in a bigger network. And of course, it has no loops. What do I mean? OSPF is so fast that the routing tables in these routers are updated quickly, such that when the packet reaches this router, it will be able to know where to go. So the thing here is, if the routing protocol is slow, it is going to update these routers slowly, such that when the packet reaches this router here, sometimes this router doesn't have the information where that packet is supposed to go. So that packet will be moved to this router, back, forth, here and then. That's what we call a loop. Okay. So OSPF has got no loop because of fast convergence. What do I mean? It updates the routing tables quickly. It is scalable. That is, you can be able to divide the area into so many areas. And again, it supports authentication. That is, before these two routers exchange information, they're supposed to authenticate. That is, this router is supposed to prove who he is to this router. And that is very, very important in our time we are living in. Okay, so the simple network management protocol. So this is used to manage a network. So when you configure SNMP on these devices will be sending whatever is happening to them to this server here. And when you're sitting here as an admin, you'll be able to know whatever is happening to each and every device. Okay. And SNMP has 3 versions. There's version 1, there's version 2C, and the latest version, which is version 3, which you're supposed to use because it has encryption. Now, of course, we are supposed to have the server as well as the agent. Okay, so an agent, this is the device, it must have an agent. And then we also must have the management information base where it keeps information. And then this agent must correct this information and send it to the NM server for management. Enterprise network operation and management. With this one, this is what we use when you are managing your network, because you can be able to analyze the traffic and then identify the need, whether you're supposed to, expand your network by adding in more devices. Okay. NTA concepts and function. So we have, Huawei has what we call the eSite network traffic analyzer. Okay. This is a very, very important device for analyzing traffic. It has what we call, it uses, the net flow, the net stream, and S-flow protocols to correct and analyze common IP protocols. Okay, so this is the net stream, also for analyzing traffic. It has the net stream device exporter, which exports traffic to the network stream collector, and then finally to the net stream device analyzer, okay, to analyze the traffic for the sake of accounting as well as planning. Okay, the transport layer protocols. Okay, so TCP is what we call reliable, connection oriented. That is, before two devices exchange information, a connection has to be established. And TCP uses what we call a 3-way handshake. That is, when this client and the server wants to communicate, the client, first of all, send a message, which we call a SYN. So it is going to be given a sequence as A. And then the server will reply with a message called SYNAC. So you can see here, a sequence will be B. but acknowledgement will be A plus 1. You have to master this as well. And then the client is going to send an acknowledgement. This time around, the sequence will be A plus 1, and then the acknowledgement will be B plus 1. And then afterwards, these two, they'll start exchanging information. That is what we call a three-way handshake. That's why we say TCP is connection oriented. Then when you talk about disconnecting in TCP connections, it uses what we call a four-way handshake. So this PC wants to disconnect. It will send a message called finish. So the sequence will be A, and then server will reply with an ACK where the sequence is B, and then the acknowledgement has to be A plus 1. And then the client will, and then the server will send another message called FINAC, where the sequence will be C, and the acknowledgement will be A plus 1. And then finally, the client will send an acknowledgement where the sequence will be A plus 1 and ACK will be C plus 1. So this is how these two, they are going to end the communication. Okay. The last component for today, which is the application layer protocols. So the common protocols that are there, of course, is FTP, and we use what we call the FTP server. A server is a computer which is there to provide services, all right? We have, this one is called the client. He's always asking from the server, and the server is what? Providing. So the server which is responsible for files is called the FTP server. And then for web, it is called the web server. And then the server responsible for emails is the email server. And then for the DNS services, we have the DNS server. So how does the DNS works? Okay, we have different types of DNS servers. The first ones are root servers, and we have only 13 of them in the whole world. So these are, I can say, the owners of the network, the internet. In the US, they are 10 of them. And then one in the UK, the other one in Japan. Okay, so this is the client. Okay, if the client is communicating to this particular server for the first time, it goes to the root server. But before that, the client also has to check in the cache server, because this is where it keeps information, that is previous information, that is the domains that this client has visited. So we have the root server, and then top level domain name server, recursive servers. Okay, so we can go to this top server. If it doesn't have information, we go to the other server, so this server becomes a recursive server. FTP, how does it work? Of course, with FTP, it uses two protocols, two connections. It has to establish a control connection, and then it has to establish the data connection where the actual transmission of data has to occur. Okay, so FTP has got two modes, active mode and passive mode. In active mode, which is default, which is used by default. Okay, so here the client sets up the control connection that is in the active mode, and then the server sets up the data connection. In the passive mode, the client does both, setting up the control connection and the data connection. So you can see here, in the active mode, port 21 is used for control connection, and then port 20 is used for data connection. This is the passive mode, where port 21, of course, it will be used to establish the control connection, and then there's going to be the temporary port, which is going to be used for data connection. Okay, how about web application? Okay, so with web, we have 3 technologies that are involved: HTML, which is used to describe a file, and uniform resource locator, which is used to specify the file location, and then, of course, HTTP, which is used for client-server communication. So this is what happens on your PC. Okay, if you want to connect to the server, the server will ask, what can I do for you? You say, I need such and such a file. Do you have the key? Yes, and so on. That's how it happens. But this process, of course, happens quickly. All right, so you see, when you are sending an email, the protocol that is involved is SMTP, okay? Simple Mail Transfer Protocol. And then when you are receiving an email, it's either POP3 or IMAP, okay? The difference between these two is that when you receive an email with POP3, the email will be deleted from the server. But with IMAP, IMAP is going to keep that email on the server, okay? And again, when the message is moving from one server to the other server, SMTP is the one which is involved. So the quiz, as I said, you don't have to panic in an exam. You take your time, read the question and understand it, okay? Which of the following is not, you see, be careful with this, is not in the TCP/IP model? This, of course, TCP/IP doesn't have the session layer, okay? Which of the following packets is the first packet of the TCP/IP 3-way handshake? The first one which is sent is the SYN packet, followed by SYNAC, and then ACK. So you see, you need to study even the diagrams that are in the materials. You study everything here if you want to make it, okay? All right. Okay, so that is that for today. Let me, invite some questions if you do have any. Okay. Yes, people. Hello. Hello.
Evening, sir. How are you?
Hello. Evening, we are there.
Yes, people. Do you have questions?
As for me, I think I still need to digest the material. So for now, I'm okay.
All right. Okay.
Yeah, I think we need to digest maybe tomorrow.
Okay. Fine. So before we meet, make sure that you go through the materials. I'll be able to post this recording on our group. Thanks very much for attending. We'll meet tomorrow, same time.